Proofs are coming back. So we're given that ABCD is a parallelogram, and we are going to prove that angle A and angle C, so opposite angles, are congruent. So we start, I'm going to do a flowchart proof for the first one, with our given information. Actually, I'd rather it be a box. That circle's driving me insane. All right, so that's our first step. So, based on the definition of a parallelogram, what do we know? What is the definition of a parallelogram? Are what? Not that they're congruent, they're parallel. So because this is a parallelogram, we can use the definition of a parallelogram and say that our opposite sides, they are congruent, but the definition doesn't say that. I'm doing it by the definition right now. That is a property of it. So AB is parallel to DC, and AD is parallel to BC. And this is the definition of a parallelogram. I'm going to be shorthand and do a parallel lines O-gram because that's how I feel like doing it. So opposite sides are parallel. Since I wrote that in my proof, I am going to mark that in my diagram. What kind of angles are A and D and B and C and A and B and D and C? They will be supplementary, but what kind of angles are they? Remember we learned alternate and consecutive. What other word goes with that?
Interior.
And consecutive interior or same side interior angles. And what do we know about same side interior angles? They add to 180. So we are going to create some equations that add to 180. So the measure of angle A plus the measure of angle D is 180. Because of these parallel lines here. So the measure of angle A plus the measure of angle D equals 180. And the measure of angle C and the measure of angle D also equal 180. So let's talk about why these are the angles they chose to add to 180 after we write the reason. These are consecutive interior angles. So why did they choose these two? Notice where we're trying to get to. We are trying to get to A and C being congruent, right? A and C. If we would have done A and D and B and C, yes, we would have had A and C in both of them. But what do you notice about these two? What is the same thing that's in both of those? They share D. So we are going to be able to get that D out of here in some way to show that these two are the same. So they did it that way so that these two and these two added in order to make sure that these D's could get out of here so we could show that A and C are the same at some point. So that's the reason why they chose those. So if they both equal 180, they both are what? They're both supplementary, that's true. But if two things are the same, we can use what? What property allows us to... Somebody said something maybe? What can you do when two things equal the same thing? A property. You learn it in Algebra 1 first. Substitution. They both equal 180. So doesn't the measure of angle A plus the measure of angle D equal the measure of angle C plus the measure of angle D?
Yes.
Because they're both 180 by substitution. So the measure of angle A plus the measure of angle C, D, equals the measure of angle C plus the measure of angle D by substitution. what can we subtract out now? We can subtract the measure of angle D on both sides, so we have the measure of angle A equals the measure of angle C by the subtraction property of equality. Here, I'll take that one. Is our proof statement an equality or a congruence? It's a congruence, which means we need to switch to congruence. Does anybody know the reason for being able to switch to congruence? Does anybody remember that? Definition of congruence. Would you guys be able to prove B and D are congruent doing that same process? Let's look at it. What two things would you have to add together to be supplementary to get B and D? Angle B plus angle C. Okay, so we could do measure of angle B plus the measure of angle C. So what would the other one have to be to get the measure of angle D? If Hannah chose the measure of angle B plus the measure of angle C equals 180, we're going to have to do something with the measure of angle D. We would do the measure of angle D plus the measure of angle C. You'd want to do the same angle again. Do you see how D and C are also consecutive? And if you add those, they both include the measure of angle C to drop out like we did. So that's why you would do it that way. Okay? So you could do that just as a way to get there. I mean, that's not proving it completely, but that would be the part of the proof I think that would be the hardest for you guys. Yes. That's where like the target is. Is that what you're saying? Yeah. Okay. ABCD is a parallelogram. ABCD is a parallelogram. Let's do we're going to prove opposite sides are congruent, so we're going to do a 2-column proof this time just to give those of you that like different things those options. So the 2-column proof is statements and reasons. And we always start with our givens. So we know A, B, C, D. What do we know because of the definition of a parallelogram? Because we have to define what a parallelogram is. What do we know? We used this on the last proof. What do we know? Opposite sides are parallel. So we know that AB and DC are parallel. And AD and BC are parallel. And that's just the definition of a parallelogram. So I should mark that. Oops. So we are going to have to add something in here to help us out. We are going to have to add something in here to help us out, which is probably not something you guys would typically think about. But through any 2 points, there is a... What can you draw between any 2 points? A line. So we are going to connect D to B by making a line because any 2 points form a line. It is a segment, you're right. So I should put draw here. 1 second, I'm going to put that the right way. Draw DB because any 2 points form a line. So now we're going to use our alternate interior angles. And you're going to have to use some letters here unless we number them. So I'm going to number them for you. So I'm going to put 1, 2, and you guys can do the same thing, 3 and 4. So go ahead and number those so we don't have to use 3 letters. What 2 angles are alternate interior angles? Give me 2 angles that are alternate interior angles. So if these are your parallel lines and this is your transversal, what are your alternate interior angles for this one?
1, 4.
Not for that one, but what is the one for those two, the purple one line?
The purple one? 2 and 3.
Do you see how 2 and 3 are congruent angles because they are formed by the transversal and the parallel and the transversal? So the measure of angle 2 and the measure of angle 3 are congruent. So we're going to say angle 2 and angle 3 are congruent. Okay, if we switch our transversal, I'm going to do a different color here, and not our transversal, if we switch our parallels and we do this one, what 2 angles are congruent? 1 and 4. What do you think we're trying to get at here? What are we trying to prove? We're using alternate interior. After our alternate interior, what are we trying to use? What are we trying to do to prove that opposite sides are congruent? What are we trying to prove first to get to these opposite sides are congruent? Who knows what shapes do you see in there? We're trying to prove 2 triangles congruent because then we can use our CPCTC. Do you remember CPCTC? Corresponding parts of congruent triangles are congruent. So what is the last piece of information? Because we have 2 pieces of information in that triangle. What is another piece of information we know about our 2 triangles here? What do they do? What are they sharing? What do they share? They share the segment of what? What property was it when we say BD equals BD? Or BD is congruent to BD? Who remembers that property? What's the reason for being able to say the same thing is equal to the same thing?
Isn't the transversal
It's like looking in a mirror. Reflexive. It's like a reflection, right? Reflexive property. So it's the reflexive property. So this is pulling things out from first semester because you're trying to prove 2 triangles are congruent here. So this is the reflexive property.
This is like, I'm trying to find like the hypotenuse, but I don't know if it's fine.
You already know the hypotenuse. Don't forget about your front, and there's another thing besides trigonometry that you can use here. You're not going to use trig right there yet. Okay, so we can now say that those 2 triangles are congruent. Who remembers the reason for that? Why is triangle ABD congruent to triangle CDB? You were right. Do you guys see it's angle, side, angle? Isn't the side between the 2 angles? Remember, like, angle, side, and we couldn't do angle, side, side. That's a joke. Side, angle, side, or angle, side, angle, or angle, angle, side. All those things we learned, side, side, side. This one is angle, side, angle. So now we can use CPCTC. Finally, right? Corresponding parts of congruent triangles are congruent. So AB is congruent to CD. And AD is congruent to BC. By CPCTC. The corresponding parts of congruent triangles are congruent. Whew. That is a lot. Your homework is mostly regurgitating these proofs, so just make sure you have your notes out. Like, do not throw these away. Keep them out, and you're just going to basically throw them back into the proof. I think that you're overthinking it, and you're forgetting about a really nice theorem that you can use there. All right, triangle ABCD, we just did this proof, is a parallelogram. Proof AB is congruent to CD and BC is congruent to AD. We are just filling in the blanks based on the last proof we did. Do you guys all have it above you? Okay, so it says, given ABCD is a parallelogram. We know opposite sides are parallel by Y. Why are those parallel? What's the reason for those being parallel? We have it in the proof above. Yeah, Brandon? It's the definition of a parallelogram. I'm sorry, it's super annoying, I get it. We can draw in, because through any 2 points there is exactly one line. What are they drawing in here? They're actually not drawing in DB. And the reason I know this is because I look further ahead. What is it saying is congruent to itself? So what line do you think they drew in this time? Do you see how the reflexive property includes AC this time? So sometimes you have to look ahead when it's fill in the blank. So they're drawing in AC this time. So AC, because through any 2 points there exists exactly one line. So AC is congruent to CA by the reflexive property. Good. By the blank, angles theorem, angle DAC and angle BCA are congruent so far. Because of what kind of angles? So what are the other set of angles that are congruent by alternate interior angles? Okay, so Ayana said BAC. I want somebody to give me the other angle that's congruent to BAC. Lexi, what'd you say? BCD is this whole angle. I want this part here, right? DCA. So BAC is congruent to angle DCA. Thus, triangle DAC is congruent to triangle BCA by what? Angle side angle. Congruence theorem. Since corresponding parts of congruent triangles are congruent, CPCTC, can we put our proof statements there? AB is congruent to CD, and BC is congruent to AD. Okay, here's my question for you. Because you guys have 30 minutes left, and there's 2 more proofs, right? So my question is that, would you prefer for me to finish all of the proofs today, give you your worksheet to work on, and then Friday, you just get to work on the worksheet Friday, because you're getting a new worksheet Friday no matter what? Or would you prefer me to stop here, you get your worksheet for today, we finish the lesson on Friday, and you get that homework still?
Finish the notes.
Okay, let's take a vote. So do you want to finish the notes today? Raise your hand. If you want to finish the notes on Friday, raise your hand. Okay, I feel like there's more people wanting to finish that. So we'll do that. We'll just finish the